We are back with Scaling Robotics. This is a series of conversations with leaders at robotics companies who have actually scaled their fleets. And we hope to democratize their hard earned lessons so that the next generation of robotics companies can benefit from all their pain and suffering and wisdom. Today, we have an awesome guest. I'm super excited about this one. Mehr from Machina Labs. Ed, thanks so much for taking the time and joining us. Do you mind introducing yourself and Machina?
Thanks for having me. Excited to have this chat. As you said, I'm Ed Mehr. I am the CEO and co-founder at Machina Labs. We do, kind of next generation manufacturing floors focused on metal structures. So we have a robotic system called Robo Craftsman. You can think of it as a general purpose robot for doing different type of, metal operations. Our core operation we people know us by is the sheet forming that we do. We do sheet forming very unlike what people have seen in manufacturing. We have robots basically forming sheet metal parts, kind of very dynamically, like almost like a potter forming clay bowl. So we don't require molds and tools, but the same robot, can drop the forming end effector, pick up a trimming end effector, do trimming, can drop that, do scanning. We're adding heat treatment, forging. The idea is you have this robot, you can have a facility that you can put 30, 40, 50 of them in there. Now you're almost turning manufacturing into a data center model where, you can program these robots to do one set of operations in the morning, making parts, let's say, for missiles. And in the afternoon, you can switch them to do parts for aircrafts, right? So without having to change anything physically in the shop floor that's specific to that product you're trying to make. My background is engineering as well. Spent early years of my career in the software AI space, both academically and also earlier in the industry. Companies like Google and Microsoft, I did long-term internships there. Eventually went to SpaceX, and this is more than a decade ago. I was a software engineer there, but ended up exploring different parts of the company. And that's where I kind of get exposed to the manufacturing problems and seeing how manufacturing is the bottleneck for how fast we can innovate, even at a company like a SpaceX, who's maybe at the forefront of kind of how fast things are being built. And since then, I have been in this space of agile manufacturing. Like, how do you manufacture things faster? How do you deploy factories faster? So yeah, the name of the game has been speed. I spent some time as part of the um, founding team of a relativity space, a company that was that is competitor to SpaceX, but using more agile manufacturing methods like 3D printing, before I started Machina.
And just to give listeners a sense, if they haven't seen the robots, which you should definitely look at a video, these robots are massive. I think of them as like these two pincers, like you said, forming metal. Can you give us kind of like a description of one, like, yeah, how do you describe it to folks who have never seen your robot? And also two, why this is, such an important problem to solve. My understanding is that traditional manufacturing, it's really expensive, kind of heavy capex, these dies that are super inflexible, and kind of Machina flips that model on its head. And yeah, would love to hear more on that side.
I think the core problem we're trying to solve is like one statement that Elon said a while back, that manufacturing or a physical product, the factory is the product, right? Meaning that once you have a factory that builds a certain things, then that product comes out and you sell it. The problem is building that factory is really hard. And the reason you say factory is the product is because factory is very specifically built for the product you're trying to build, right? So what we want to do is we want to build a factory that's not that way. It can similar to how a computer can run a web server or AI training software. Can we turn a factory into something that's a little bit more amorphous, right? Like you can have it make aircrafts in the morning, but then switch the software and make missiles or other types of products. So yeah, for folks who haven't seen our systems, our factories are basically a collection of this system that we build. We call RoboCraftsman. It's actually pretty big. People look at the video and they're like, they don't realize what the size of it. It's like 40 foot by 30 foot kind of width and length, and then it's like 20 foot tall. It's a pretty large robotic system. You have two robots on two ends today on this current version. In the future, we might have even more robots. But these robots basically collaboratively work together to do different operations. The operation that we are very known for is roboforming operation. And you can see these robots basically like almost like a craftsman. You said pincher. They come in and pinch and deform a sheet of metal incrementally into shape, and they get very complex shapes. Let's say a fuel tank for a missile or a body for a drone. They start from a flat sheet, which is kind of fixtured between these two robots, and they collaboratively deform that sheet by pinching it and moving around into a final shape. But that's not the only operation it does. It can pick up the next tool and do the next operation, right? That can be trimming, that can be scanning and doing QC. What our goal is that this platform constantly learns new what I call trade, not just tasks, new trade, knows how to do the next manufacturing operation. We're working on heat treatment now. Like the robot can pick up a heating end effector and heat treat the part. Forging, we can do like thicker material that we need to heat up and then deform. We're talking about assembly and welding maybe down the road that we're adding to this system. But the idea is yes, imagine a factory full of these robotic systems that each of them are doing different tasks, and collectively they can build a very complex product. That's where we're going towards. Today we do mostly sheet metal operations.
And I love the first thing you said. The factory is a product. I think Elon also said like anybody can build one car. Now show me how you can build 1,000 cars, and then also not kill your company in the process of doing that. Um, for you guys, in terms of scaling, can you tell us a little bit more about what's the scale of your fleet? I know you're building out some factories. What's going on that side?
Yeah, as I mentioned, so these are pretty large systems. Today we manufacture four of these, roughly 4 or 5 of these a year. Right. And I think we're working on serial number 19 right now. So 19 of them that's come so far. A facility that has 50 of these deployed can do up to thousands of, for example, advanced structures. Think a missile airframe or a UAV airframe per year. So that's what scale looks like for us. Right now we have 2 facilities. In one of these facilities we make 5 of these a year. In another one we have around deployed 8 of these. We are about to deploy our 3rd facility, which we're going to have 50 of these, right? So right at the cusp of kind of almost 5 to 8 time our capacity increase. So it's an exciting time. But yeah, I think we operate our own factory. So not only we need to scale the production, but we also need to figure out how we operate these things at scale, so that we can actually make thousands of metal structures a year using these robots.
You hinted at this earlier, but going all the way back, I want to hear about what actually made you become a builder. What are some of those early influences? I know you went to kind of a school where tinkering and shop working was encouraged. You have your Persian background. I think Persians have really strong engineering culture. But yeah, would love to hear some of those things that you remember from your childhood and growing up that made you want to build things.
Very early on, I started kind of tinkering with things, and that was partially the school, partially my dad was also in manufacturing business, in automotive. For a portion of his career, then like industrial machinery for a portion of his career. So I will always, I would go. I remember I would go to a factory for take your children to work day, and I would see what's happening in these factories. It was very exciting. I remember recently I was back in the Toyota factory for a visit, and I was like, kind of remind me of my childhood. It's almost like being in a casino. Like that's the closest thing that I can kind of describe. It's like 2 levels of machinery. Like if you especially go to a very advanced automotive factory, there are cars going above your head and everything is moving at the same time. There's these AGVs that are going around that are making different noises. And I mean, for anybody who hasn't been to a factory, I think they should probably set this to be one of their bucket list goals. Go see a factory. And I think it's one of the most entertaining places to be. And as a kid, I would go to these factories and be like, okay, this is super cool, right? Like being able to be in this thing that's like you go to a Toyota factory, like every 60 seconds a car comes out. And a car is a very complex product, right? Like how does this happen? How do they created this massive orchestration and coordination that everything comes together in this, thousands of parts that need to come together to get this complex, reliable product coming out in the end? It was very interesting to me. It was actually like a place where I felt like, it is an exciting place to be in. So I always had that affinity to build things and for the factories. But the problem was, I think when I was in my high school, we started to start getting in at the beginning of this phase where we started, outsourcing manufacturing to Southeast Asia, and it started to feel like this job that's not that desirable. It's low value add. And I think I've kind of fell into that trap too, the cultural trap, because we didn't get it like it wasn't as exciting for the people. So I was like, oh, I'm going to go to the world of computers because that seems like much more exciting, culturally is much more valuable, and I can exercise my freedom of expression in a computer much more so than we can do in the computer, than in the factory. um so I went down that route, but then it became for circle when I went back to SpaceX, right? I thought I go to school, I become AI ML person, a robotic person, and then go work in companies like Google and Microsoft, where at the time they were like really offering crazy salaries for people who were graduating from good schools. And they had all these perks where, like, you have free lunch and free dinner and free this and free that. And I was like, okay, this is an amazing place to be in. And I went into those places, and honestly, I was depressed. Like I was working when I was interning at Google, I was working on ads team, and I felt like, yeah, I'm working on optimization of ad for this product. Great, I think it's a great business, but it didn't feed your soul. um you know and even though, like, we're accounting for creative time to be only 5 hours a day, like they actually expect engineers to be only 5 hours a day creative. And I felt like that's just ridiculous. Like, I mean, like, why can't I, um so it became this kind of this hole in my soul around, like, hey, I'm not doing something useful. um um and this doesn't seem like overall is contributing to the society as much as I would hope as a kid to be contributing. And then until I got a tour of the factory at SpaceX, and I initially I didn't believe them. They were like saying, oh, we're making rockets, and I was like, no, you're not. There's no way. That's, countries build rockets. Like, there's no way, like, a group of 5 or 6 of you, like, that are sitting in this small recruiting booth are part of a company that builds rockets. And then, it's like, hey, come for an event. And I remember going to their facility, and I was like, kid in a candy shop. I'm like, no, no, actually they're building. And I got reminded of that feeling that I had when I was a kid, going to it with my dad to the factory. And I was like, yeah, this is what I want to be part of. I remember I had an offer to go full time at Google for twice of what SpaceX offered me, but it still was like, okay, I'm going to go to SpaceX because it seemed much more fulfilling, right? So the passion started very early on, but then there was a period where, like, I was absorbed by the computer world, and it's an amazing world, and I think, but with the AI, it's kind of that door is closing a little bit, in terms of creative expression of engineers in that space. So I think, more than a decade ago, when I got introduced to SpaceX again, I think I got pulled back into the charm of the manufacturing world.
Yeah, that's a yeah, crazy full circle moment, especially yeah, back in the factory. Those first few weeks or months at SpaceX, I can only imagine it was like being culturally punched in the face, right? You're coming from Google, where like you have to get your massage before you get your smoothie, before you join a meeting to then start writing code when it's 3:30 p.m. and you better not be in the office after 5. And then you're at SpaceX, right? And it's like notorious for this like hardcore culture. That's the word I always associate with SpaceX is hardcore. What was it like? Like, what are those? What were those? What was that feeling like working there? Those that in the early period, and the what do you still think about today when you think about those moments at SpaceX?
I went there, and I think immediately I felt this, to your point, like cultural shock. First of all, like, they were the most mission driven people I've ever seen in my life, right? I where when in at Google we were talking about all these perks and salaries or whatever. At the SpaceX lunch, we were talking about, like the cosmos and how it came about, and how when are we going to get to Mars. And I was like, okay, like, this is the caliber and excitement that these caliber of people have is very unparalleled. So that one really drew me. And then the other piece was, like, it was a little bit of a wild west, right? So it was like, hey, like, go figure out where you can contribute, and then you can contribute there, right? And as long as you build something that's useful, people will use, and you can do more in there. So that was also pretty exciting to me. But the biggest thing, so there's a lot of things that was, in this side that was exciting, but the biggest challenge was, like, I realized how, even though the culture was so much better, the speed of innovation was much slower, right? and it was only being pushed by like sheer power will with people there. They didn't necessarily had all the tools, but like they really had a lot of will and a lot of mission drivenness that allowed them to go really fast and sleep on the conference room tables. I remember I was part of the team that did inventory count for at the end of the year. We built this like little piece of software to do it more easily, but we slept on conference room tables to make sure that happens, right? So the excitement and the culture was pretty strong, but I also was at the same time really surprised by how slow the hardware development is. If you look at a company like SpaceX, 20 something years that are about to go IPO, two rocket families, because it's really hard to build, complex hardware products. You have to almost build a factory for it. Both of these rocket families are out of two different buildings, one in Texas, one here in LA. Which is, compared to a software where like, a group of 5, 6 people can sit together and build something and deploy it on thousands of servers and suddenly it's available across the world as a product. That was also another shock for me. It was like, oh shit, like things are like structurally and technologically slower here, even though the people are so motivated to go fast.
I think that's a nice segue too into why you started building Machina in those early days. Um, One thing that's fascinating me about your journey is that when you all were still in stealth and still building the first few iterations of the product, you were able to secure contracts with I think the Air Force and NASA. Tell me a little bit about that. How did you pull that off? And what are some lessons there for other folks as they build their first fleet of robots and go to market with it?
Yeah, when I left, my previous job, which was at Relativity Space, I took this 1 year of kind of doing consulting here and there, working with a few of the companies that I knew, but in a very short term capacity because I really wanted to explore, you know, if, I wanted to figure out how we can build next generation of factories, but to figure out where and who and what product we need to sell, right? And coming from 3D printing background, I thought it would be there, but then started talking with the customers. I realized that there's a lot of other need that are probably even more important. So you asked why, like right in the beginning, we have customer contracts. The reason for it was like, 1 year before we started the company, we started talking with the industry, right? Everybody that we knew in the industry, we knew folks from Air Force, we knew folks from NASA, from companies that we worked for, like SpaceX and others. And we started being like, hey, if I build this thing, would you use it? First of all, the answer to that should have been yes, but also not just yes. The answer would that would be like, hey, I'm willing to pay for your development if you do that, right? Because we realize that if something is not as valuable that they're willing to kind of put some skin in the game, not just give you an order, then it's probably not that high on the list for them. Right. So almost even before we started the company, we had this interest from NASA, from Air Force, from other companies like SpaceX. It's like, hey, if you do this, we'd definitely, um, the need is there and we're willing to actually put more skin in the game and help you develop the first early version. And that kind of became the foundation of the company. We're like, okay, we're not going to start on any project unless the customer is actually committed with some dollars toward making of the product. So and I think it was a good choice. What you don't want to do is go build something that you think is really great, and people said yes, I want it, but like they didn't really put any skin in the game, right? So it was a very core fundamental kind of like policy for us. That every contract that we do, every effort we do needs to be paid.
I love that. It's so burning that the customer is like, I don't just want to buy it. I'll pay you to make it for me, and then I'll buy it from you. Um, okay, that's great. You have these contracts, but you still have to make the damn thing, and you're doing it on a shoestring budget. Something that I think this generation of robotics companies that I see is, we're raising massive rounds out of the gate to build our first demo. I think the environment that you guys grew up in, it was not you're not able to do that, right? Like, what was it that allowed you guys to be lean with your engineering and get to those first few iterations without burning a ton of cash up front?
Yeah, I mean, we annoyed a lot our engineers, the engineer team, I think, with that, right? Like, they were like working on definitely shoestring budget, and they were like saying, like, not only you need to make this technology, but you need to make the customer happy, which is something engineers do not like. They do not want to sit in customer meetings and take shit from the customer. Pardon my French, right? So, so we definitely need to have to get comfortable with folks. Is like, hey, like you need to be very close to the customer and do this work. And I think a lot of our early engineers were like pretty pissed about it, but I think it was pretty important for us to do that. Um, the 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 real piece really is like, again, I'm actually excited all these companies are getting funding. I think it's something we need, and we need to put more capital in it. Hype is not always bad. It means that, like, hey, more resources going to go into this space and something crazy might get built, and I think it increases the possibility of that and probability of that. But I think as a company, uh, what forces you to do is to be very iterative and incremental, right? Instead of trying to really look long term, and build something that maybe like 10 years and 10 years is going to be useful, you start looking to build something that is going to be helpful in a bit. So how does that manifest itself in manufacturing? For example, most of the robotic companies are looking for autonomous solutions, right? And I think autonomy is really tough to achieve in robotics. Um, so right off the bat, we knew that autonomy, like fully autonomous, no engineering involvement, no technician involvement, probably not going to happen, or it's going to require a lot of capital. So we were like, okay, we need to build a system that has human in the loop very closely, right? Um, and the reason we know it's not going to happen is because also, like, for autonomy, we didn't even have enough data. The people who build these, like, models like chat GPTs of the world, they have the luxury of being out there in the internet and getting the data they need almost for free. For us, we were talking about how the material goes through a process, and that data does not exist. So we built our systems to first capture a lot of data, but operates and create something useful without having to rely on having a lot of data and building those models, and having the human in the loop who can make adjustments. So that was one of the things we did early on. Have the human aggressively involved, get something built, get the feedback back to the human. Human looks at it, make adjustments, feeds it back to the machine, and then over time, we're capturing enough data so that we can kind of increase the productivity of the human who's involved, right? And not have them do every little task or every little annoying task. So that affected our product strategy, right? So we built the product with humans in mind. Even today, big portion of our team is involved with building the right UI for the software, the architect software that we have. It's a CAM software that we use to get our robots ready. The UI for the robotic system, so that it's very intuitive and user friendly. Um, so yeah, that was a big thing in terms of being able to scale with human. But the product you're offering needs to be useful enough that the customer want to switch to it, even with the humans involved, right? So go after an application where there's enough margin that even if you include the human full time in it, you're still generating enough margin that the customer is willing to pay for that, right? And it's 10 times better, or some benefit that the customer is willing to pay for, even though it's not fully there yet.
On the culture side, you talked about, we are customer obsessed. We're going to be talking to our customers all day long, whether you like it or not. We're going to iterate relentlessly, and we're going to be pragmatic, right, and deliver value, day zero instead of waiting till day 1,000. Um, I'm sure you get asked a lot about, from your previous at SpaceX and Relativity, like, what are those pieces of culture that you brought with you to Machina? But I want to ask the opposite. What are the things that you saw at those other two companies that you're like, this is not going to be how Machina builds, and you kind of diametrically opposed to that?
Yeah, I think it's a good question. There's a lot I appreciate about those companies. So this is actually a pretty good, tough question. Um, I think, I think SpaceX. The problem that SpaceX had was it the, you can. It's not easy to build another SpaceX, right? So culturally, I don't think it's a scalable company, right? Culturally, right? Like, the way SpaceX happened, if I really want to be honest, is like a lot of people put a lot of effort. They were so driven by the mission that, they sacrificed a lot out of their lives. Um, I mean, hopefully it's paying off now, through this IPO, right? And a lot of them are getting rich, which is great. Um, but you're not going to change the society from a software digital first service economy into a builder society with that culture. It's just so intense, and so uniquely attracting certain type of people. Like if you look at, SpaceX is not really good with retention, right? Like it's not keeping its people for long term. Um, there is, we used to say there's like two class of people in SpaceX. They're like, the people who've been there for first couple of years and they're working really hard and they're drinking the Kool-Aid and that's great. And then there are people who have been there for 10 years. And then that middle piece is really few people are there. So it's like either people who graduated to the year 6 or 7 or 10, or to people who are very early on. And the people who are 6 and 10, they just like internalize this culture, and now they're just pillars of SpaceX and have all the tribal knowledge that they can help people kind of connect the dots. And then they're like early, like hardworking, passionate people who are like doing a lot of work and sleeping on conference room tables to get shit done. But then that middle layer is just like it's a kind of valley of death. You need to like kind of go through it, and very few people go through that. So I would love to, I think if you want to have a society where in it we have 10, 20, 30,000 SpaceXs, then we need to have a culture that's attractive to a lot of people. We need to make building attractive. We shouldn't also only rely on sheer power of will and those few people who are going to be able to do that to and are like super intense and super obsessed to be we need those people, but it's just not going to be scalable, right? So we need to turn our culture in a way that the other types of people who want to be part of this makers culture, this building culture, and you want to change America into a builder nation, to also participate. So I think that's one thing I would say from SpaceX that I would change.
It's not just taking a handful of people and turning them all the way up to 100, and like you said, maybe potentially burning them out. It's like imbuing it from the bottom up in the culture of how we think about building businesses, how we think about building things. Yeah, that
And be
makes a lot of sense to
sustainable.
me.
Like, like some people, are not going to be as intensive as others. And some people require more breathing room to be creative. And again, if you want to be living in a world where like we have thousands of SpaceXs, we need that type of a approach to the culture.
That's a really refreshing take. I think like a lot of times, I mean, I've learned so much from Elon. I've read practically everything about him. I'm sure you've done the same. But it is refreshing when you can sometimes see on X like people LARPing to just be exactly like Elon and not be authentic to themselves, or like what it takes to build a business that's enduring for 20, 50 years, etc. Um, Fast forwarding to today, this is no longer the R&D kind of shop that maybe it was, all those years ago. When you're thinking about going from a few robots to, you said now the next factory will have 50 and one after that will have more, and you're scaling, what are the big things that you're focused on that are different from that previous paradigm? What are those? Okay, as a team, we need to get X, Y, and Z really, really right for this to go well.
I think the biggest part of scalability in robotics company is repeatability, like how well your operation are keep repeating the same way, especially in manufacturing, right? You're building the same thing over and over again. You need to make sure you're consistent. Yeah, the outcome is consistent. And that's not easy task, right? Like a lot of people kind of overlook it. Like it might take 80% of 80% of the work is kind of building something new, but then the last 20% sometimes takes 80% of your effort, right? Like that last 20% to make it really reliable, bring our uptimes high, make sure the cells don't go down, make sure they're user friendly enough that like if something comes down, it can easily be repaired. Make sure the support staff is build the right relationship with the folks on the shop floor to help them with any issues that arise in a way that like the line doesn't go down for days, or the cells don't go down for days. I think that is the big area of focus for us, right? Like, right now, actually, one of the things we're partnering with one of our investors, Toyota, um, to bring some of those Toyota techniques, Toyota production system techniques, which is well known in the world, to start really efficiently run our operations. Build the cells in a very efficient way where the waste is minimized, the takt times are lower. The same thing when we're operating our cells, do the same thing. So like really embracing this Toyota production system in our both production of the cells and production of the parts using our cells. That's probably the biggest challenge. And then I think from the So that's from the engineering and operations side. From the finance side, now suddenly like we're going from a engineering company that really was focused around technology into building facilities. We're about to deploy facility number 3, which is going to be our biggest facility yet. And right after that, we need to deploy facility number 4, which is going to be the first foreign facility. So starting to develop also operational excellence in terms of how we're going to finance these things, looking into larger debt markets in order to finance these facilities. How do we build enough legal capability to operate a factory in outside of the United States? Um, um, Hiring culturally diverse teams in different locations that would still be very much working with the headquarter really closely. That's another challenge. But yeah, from technical perspective, we need to make sure the machine works and machine works persistently.
So many things there. Everyone's like, yeah, when I first start the company, that's the hardest it'll ever be. No, it just gets harder and harder. Um, so a few things to pick apart there, but I think one of the really interesting things that you said was we need to make sure that our robotics engineers, hardware engineers, software engineers are in lockstep with the folks on the factory floor, right? Like the people who are sustaining the robot, actually running, kind of, I guess, executing the missions or whatever. What does it take to do that and do that really well?
Number one is they need to deploy the next factories together, right? Like you can't split these teams too early, right? I think the same teams that are deploying factories need to be really even almost be part of the, I mean, in our case, being part of the same organization as the engineering organization, right? So that they can like work very closely together. Um, the second piece really is exposure, right? Have that team kind of do brown bags, launchions for the other team, for the production team, and the production team do the same thing for the engineering team. Really maintain their contact. Um, the 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 thing that is also like kind of becoming more interesting as with this, I guess something that's like new that was not the case before is that we see that even from the nature of the work, we before we had like blue color and white color. Now we almost have the merge, right? Right, like people are like I call them teal color, like you know engineers are on shop floor because they want to be, not because like we force them. Because now with AI and with other pieces, their productivity is increased, so they can kind of like be more full stack as opposed to try to do certain things and pass on to the other team. So also the team itself are becoming hybrid, right? The manufacturing engineers that are on shop floor learning more mechanical, right? Mechanical engineers are becoming more involved with the shop floor. Even software engineers are more on the ground learning new skills. And I think one of the accelerants here was the AI, right? Like people are learning these new skill sets much faster than before. So everybody is becoming a little bit more full stack, a little bit more jack of all trades. So bringing them closer is actually easier because of AI.
And one of the other piece you mentioned, the other side is the financial kind of the capital raising, how what that looks like, the allocation, stuff like this. Um, I think you have a really difficult job of telling the story, right? Of like how we become to dominate the world and why we need these hundreds of millions of dollars. And I'm sure it's tough when, like you talked about the software world, there's like these AI companies maybe kind of going vertical. You can argue about the enduring value of both of your businesses. I think I have my bias, but uh how do you tell that story? What are the things that you really are trying to get across when you're raising capital, especially capital at large amounts now at your scale?
This is something we were talking with the team. Your story need to thread all the way from today to the future. And the further you can go out in the future, the better. But you need to have this continuous thread. You need to be able to like, how am I going to go from today to this 20-year, even if you're going out to 20-year vision that I'm talking about? Um, and I think everybody in the company is working on different version of this story, right? So they all need to see that whole picture so that they can understand, okay, what is everybody else is doing, and they can work for each other, with each other collaboratively. So if you think about it, folks on the shop floor are working on version 1, maybe version 1 that's currently deployed, right? Engineers are working on version 2, right? Like they're about to deploy something new. You know, The sales team, because the sales cycles are so much longer, are talking about version 3, right? And then because like by the time they sell the product, we're already at version 3, right? Like because it takes a year to, let's say, turn over the customer to come in and be a customer. Marketing is talking about version 4 because marketing's horizon is much further along. So, and that horizon might be 2 years, 3 years, right? And then the founder of the company might be talking about even version 5 because we're talking about these 5-year, 6-year, 10-year investment cycles, right? So I think people need to be aware of that. A lot of times, people get confused and like, why is the founder talking about something and the engineers are talking, but all of this needs to have a thread. The people who are working on version 0 need to see how version 5 is possible. And people who are working on version 1 need to see how version 5 is possible. And they all need to see that thread. So I would say you want to tell the most ambitious story that has grounds, and everybody in your company can feel like, yeah, I get the path to that ambitious story. The more ambitious and believable story that you can tell that is grounded in truth, the larger, you're more successful in kind of like telling the investors and the people who want to be part of your team, either as an investor or as a talent, that this is good use of their time, right? And this is good use of their resources. So because even the investor might start from version 5, but then throughout the diligence goes back all the way to version 0 and version 1. So you need to be able to walk them all the way back. So I would say, hey, tell a story that you can cohesively tell from today to the future that you're describing. Don't go further than that because then you're going to blow up. Don't also cut yourself shorter by going too early and say, hey, I'm just building version 2. And then everybody would be like, okay, then that company's not as valuable, right? Because when you're fundraising, you're selling future, right? You're selling your future revenue streams, not your past revenue streams.
Yeah. Actually, I'm super curious on this. I want to pull on this thread more. Also, just as another founder, um, for Machina, what's the thread there? You've talked about, we have all these different kinds of end of arm tooling. Maybe we're gonna have multiple robot arms. There's more applications of this. What's the thread there? Obviously, don't spill any secret sauce that you don't want to. And then and also, how are you communicating that to the team? Does that mean like, hey, during this all hands, I'm going to tell you guys what I'm thinking about in 5 years? How do we make sure that everyone's actually like rowing in the same direction there?
Yeah, that's a very good question. Okay, so it starts with this, right? Largest version of the story is America needs to be reindustrialized. That's because it's becoming, there's multiple effects. So we can talk about the national security effects, where the fact that by outsourcing manufacturing to other countries, Southeast Asia, we created this threat in terms of like now they can pull the carpet from underneath us if anything happened, any type of a conflict happened, and we can manufacture our essential things, right? So we need to be reindustrialized. In order to do that, we need to have a different type of society that is very excited about building. And we need to also go build things that are something that China cannot compete in. Because if you go just head to head with China, there's a famous thing I think Peter Thiel says is that like if you're competing, you're losing, right? Like so you don't want to go compete, especially with somebody who's so far ahead in reindustrialization. So we need to identify where can we win the game. And for me, what I see is we need to go in the area of high flexibility where speed is the kind of the enabler for our integrators. We need to have fast manufacturing that can easily switch from one product to another. That's the area that China is not that great. China's built a lot of rigid, large factories that supply the same type of work to the rest of the world. What we need to build is these factories that are much more agile. They can build one thing one day and another thing the other day. There's not a huge investment in terms of changing the product. Changeover is not expensive, both in terms of time and in terms of money. So starting from that end position, which puts us in a much better strategic position than China, work your way backwards. How does that manufacturing floor look like? How does a flexible manufacturing floor look like? How does the machinery that does one thing in the morning and then another thing in the afternoon looks like? There's going to be a lot of robotics involved, because we need kinematic freedom. We need high accuracy, high force, because in manufacturing, those are the requirements. We need advanced software that can figure out how we can switch from one design to another. We need a orchestration layer or a design layer that turns intent into a final product really fast. So you start from there, then the pieces of the puzzles become clear. And that landed us, okay, one of the most important piece here is a manufacturing system that flexibly can do different types of operations. That's what RoboCraftsman is. Um, and then you come back to earlier, okay, what does RoboCraftsman operation needs to be first? We landed on sheet metal forming because it's the largest metal processing sector, doesn't really have an agile way today. And which sector do you want to apply first? Even though the long-term goal is to industrialize the United States, a sector that requires agility today and also doesn't want to go to China for manufacturing. So defense is a very good place to start, right? So you work your way backwards and kind of logically build the steps. And it says, okay, today I need to build a sheet metal forming machine that sells to defense, right? But then all the pieces are there to get to where you want to go. You can even now go further earlier. Hey, it doesn't need to be, because it's in defense and we have some room for margins, it doesn't need to be fully automated. We can start with humans involved and work on high-end products like, advanced missiles and advanced aircrafts where we can actually deploy humans into these applications to gather the data before to go to lower margin business where we're more cost sensitive. Now there's a cohesive story, right? Like now people know what's going to happen year one, what's going to happen year 2, year 3, year 4, and what are the milestones. And then you can see like, oh, year 10 or year 20, you're looking at distributed factories across the United States, even maybe allied. That's why we were going to UAE, where they're doing different types of manufacturing operations autonomously near the point of need. These robots are learning from the data that they've generated over the past 10 years, learned a bunch of processes, and now they're constantly scaling, and we're getting closer and closer to this data center style, Amazon style of manufacturing, right? But everybody sees the steps and everybody's excited about getting to that next step, both investors and also engineers in the company. But they also understand the most important thing today is making a reliable sheet forming machine that sells to defense, right? And that's the most important thing to do, right? So, does that make
I
sense?
love that. Yeah, it does. It's pretty perfect, and I think almost it's like framing it as okay, what's the most optimal way for U.S. to compete with China and reindustrialize? And the first principles answer to that problem is Machina. Machina is the answer to that, and I love how you kind of pose that. Um, so tactically, as we're building this factory, I think you said you're learning lessons from your partners at Toyota. I also saw that you visited Send Cut Send recently. I think they're doing awesome work. Um, Maybe yeah. What are a few of those lessons that you saw? Like, wow, I don't think anybody appreciates just how great this manufacturing process is that you're going to be stealing from Machina now.
Obviously, our focus really is in building the next version of machines that are technologically enabled to do this high mix production. But then those machines need to go to these operational environments, which I told you, like, we're deploying our facility number 3, it's going to be 50 of these. So we need to really be also good at operations, because even if you have the best machines, even if you have the machines that can do many things, and it's flexible and it's agile, your Achilles heel becomes how fast are you operating this machine. So I have been learning from Jim at Setkansen, and I've been learning from Toyota how they're doing it. I mean, like, Jim is doing an amazing job. Think about it. He's probably one of the best operators we have in manufacturing space today, in terms of, CNC operations, bending, hemming operations, simpler operations. But he have turned those simple operations into a machine that can be turning orders in less than a day, right? On those type of products, right? So by going there, I saw a lot of like really, in Toyota world, we talk about Kaizen improvements, right? How do you lay out your factory in a way that things flow smoothly? Um, how do you do packaging so that the customer gets the little delight out of the package they receive, but also protects the parts and signals to the operators that we are doing high value, respectable business here, and you need to be proud of what you're doing. From Jim going on the shop floor, getting the respect of everybody was on the shop floor because he's intimately involved with what they're doing. To building an environment from the light perspective, from the tools perspective, that is attractive to the new generation of people who are going into the workforce to be in, right? Most of the people think of manufacturers as these dingy rooms and greasy machines, and that's not the case when you go to Senkatsen or Toyota. It's like a theme park. It's beautiful, and it's exciting to be there. The lighting is amazing. The collaboration between the employees are very respectful. The workstations are easy to be in. The tools are the right tools. You're not going to hurt yourself. So there is the beauty of what Jim and maybe Toyota are doing is just they've done all the little details they've done right, and that's what it takes to do a good operations business, and that's something we need to learn, right? So we have been focused on building technology. Now we need to learn how to operate it, as we're scaling. So being in those places is very valuable to me.
I'm also reminded of the Steve Jobs story where he wanted to paint everything blue in one of the factories, and it's like, yeah, it's like being on the shop floor, respecting those folks, and showing that, yeah, we want to build high quality business here, high quality experience. Um, Kind of moving towards the end of our conversation. Um, Fresh off Series C fundraising, a lot of money in the bank, but also still reminded of the early days, right, when you were on that shoestring budget. How do you keep that same leanness when you operate when you're flush with cash, and keep that same engineering discipline there?
Yeah, I mean, that's cultural, right? I think the leaders should live frugally, and then I think from there it cascades to everybody else, right? Um, if the leaders prioritize frugality and creative ingenuity around like how do we do things with the least amount of waste, I think that cascades. Um, it also starts with your hiring. One of the bars I have for hiring, I think people like ask me like, hey, how do you think about hiring? Um, what I think about hiring is like, hey, I want people who they can potentially have access to unlimited resources but use them very efficiently. So what I'm trying to answer in my head is like, hey, if I define an objective with this person, first of all, would that person be excited about that objective? But after that, if I give them a unlimited credit card, will they go do it in the most efficient way, right? And with least amount of potentially support. That's what I'm trying to answer in my interview process, right? Can can this person define their own, get excited about the objective, define the steps, have the ability to use a lot of resources, but despite that, they're very efficient and do it the most efficient way. Um, so start culturally. You want to build, hire people that are that way. Um, and then also, um, at the same time, once you hire those people, you need to actually entrust them. It's kind of a little bit counterintuitive. That's what I'm saying. Like, give them a credit card. But those people actually end up being very respectful to resources, if they're the right hires. And if you end up finding somebody who's very resourceful, he's very, very, very wasteful in the resources, then they might not be the best fit, right? So really, it's a cultural. Like, I don't think there's not a especially as the company grows, you have more resources. There's not a whole lot of administrative things you can do to stop that. It really needs to be in the DNA of the people you hire.
Ed, this has been a great conversation. Thanks so much for imparting all your wisdom. To close, I have a quick lightning round for you. So 3 questions. Yeah, let's do it. Um, First, what advice would you give to founders or engineers who are about to scale their first real fleet of robots?
I think the most cliche advice is get started as soon as possible, right? I think if you're scaling, start scaling, build the processes first with humans in mind, and don't over automate too early, right? Especially in the manufacturing space. Rely on a lot of people very early on. I think a lot of people make a mistake of when they're scaling right in the beginning. They're like, oh, I'm gonna just like remove a bunch of pieces out and I'm gonna automate it, and then that's usually blows up, right? Like, because like you wanna start with people and slowly remove, right? And automate with the help of people. I think this is actually one of the TPS techniques, is that you want to do these Kaizen improvements with the people involved. So you want to have a lot of people initially involved and then really have a very close pulse of what is annoying them, what are the wastes of their time, what are the ways where they might be hurting themselves or like being slow, and then start improving those things. So I think less fundamentally in terms of scale, and more incremental, right? Because you already built the technology, now you're deploying it. You need to slowly get the people's help to to improve it. um Number two, only expand if the customer need is there. I think this is sounds very obvious, but it doesn't always happen. I think people just get too excited and jump ahead of it, especially because they were like, "Oh, it takes me 3 years to do this before I get it." Like, it's just, don't do it. Like, try to get signal from the customer very early on before you expand. Um, and I think number three is measure. I think this is, again, might be a little bit of cliche, but the only way we're going, like, as we're going to this next stage of kind of the world and the AI models, your asset is your data. So measure every step. Have a very good fleet management system that kind of can can capture all the data from your sensors, and in a robust way it can centralize so they can use this data. You want to be very, scaling is a science. It's not, and it's not like, a gut feeling. You need to measure everything and then use those measurements to improve what you need to do next.
Your passion is just so obvious for what you do. Why do you love manufacturing and robotics?
you know for a while we thought the ideal world, like if you look at it in 2016, 2015, among engineers, ideal job was, I'm going to work behind my computer, and then I'm going to go live in it like a remote cabin and be in somewhere peaceful, work on my own schedule, and all I need to know is I have a computer and I can work with anybody in the world. And I think in an ironic way, COVID happened and forced that everybody to do that. And then everybody was like, "Whoa, this is not what I wanted," right? And I think it's because at core we are human beings who want to be out there, who want to be involved, who want to be close to the physical world that we participate in. Um, and then right after that, AI came about, right? And AI also almost closed this door to like the amount of information work we need to do behind a computer. So I think to some extent with COVID and AI, this door toward doing information work behind laptop almost closed, and showed us that, hey, maybe we should now look outside the screen and look at the world. And now there's this beautiful physical world that's like, with the access to space also suddenly opened up to even be to further exploration. Now we can go to space hopefully soon in a very low cost way. So I think, to answer your question, I think this is the next kind of wave of what humans are going to be excited to do. I think we spent the past few decades in the digital world, and for the first time, we see the aperture to the physical world opened up again with some of these few technological improvements. It's such an exciting place to be. And in order to explore this physical world, we need robots, and we need to extend our muscles. And I think it's just, there has never been a better time to be in the robotic space. I think everything has been aligned to this moment. Um, to have a very exciting, I call it like American road trip 2.0. I think we're back out in the physical world, and going to explore again, and we better have robots to help us.
And last question, how can the Scaling Robotics audience help you?
We're hiring a lot of people. Like, if you listen to this, like, I think we have like as many roles open as we have employees in the company. uh Almost. So software, hardware, mechanical, electrical, manufacturing, engineering, finance, operations, technicians, all across the board. Machine learning, AI pieces, simulation. So yeah, take a look. And if you're a founder, start building. I mean, this has never been there's never been a better time to build.
There's never been a better time. I'll make sure to link the hiring in the description. Ed, thanks again so much for your time and for what you're building. Really enjoyed this conversation, and we'll see you later.
Same. Thank you.